So we're gonna kick off this Tech Field Day and start talking about the routed optical networking architecture. This is a major architecture shift that you've probably seen some of the announcements that we've done around Cisco Live, and it's really around how can we converge IP and optical networks and drive this major transition as we're moving towards 400 gig. So my name is Rana Dasuki, and I lead product management for mass infrastructure, service provider routing products, XR technologies, and also architectures. So today we're going to cover two main topics. We're going to start talking about what is really this routed optical networking architecture, what are the building blocks, and how can we actually take our customers to that major transition, and what's the journey that our customers can really embark on to realize all the benefits. And we're going to talk about what we're adding and what we're building across the portfolio, from routing, optics, optical, and automation to make this a reality. So if we start first by looking at the market transition and really ask our question of why, right? Why this major transition, and how can we drive this convergence of IP and optical networking? What we can actually look at is actually two things, right? So one is it's really the economic benefit of doing that, and there has been a shift in economics that enables this transition. And second is really the technology evolution and the new innovation that we were able to add, whether it's in mass scale routing silicon or into the transformation of having optical systems like typical transponder shells, being able to move to a much more compact form factor, having a pluggable optic that's the same form factor as QSFP-DD that can plug into the routers. And for cases where you actually have subsea type applications, you can actually move to a form factor that's just 1 or 2 RU, that's very compact and can really save on a lot of the power, space, and the cost as well of the typical transponder chassis shelves that you see here. So if we take a look at the economics, right, and what has really changed, if we take a look at how we would build a 10 gig bill of material, we're going to see that the majority of the cost, maybe around 90% or so, is actually going to be in the price of the router port, and the rest would be the price of the optic. But if we move towards 400 gig, it's actually the total opposite. And the price of the optic is actually more expensive than the price of the router port. And with this major architecture and economic shift, we should look at the architecture quite differently and see how can we build networks in a much more simplified way, drive convergence, and allow our customers to really get those TCO savings with this shift in economics. And if you take a look at what's really happened on the routing silicon side, there has been massive improvements, huge scale that we're able to achieve right now. And we launched back in December 2019 the industry's first 10.8 terabit router MPU. And we recently also launched the 12.8 terabit router MPU, which basically allows us to have a single router that can scale up to 260 terabits of traffic. And for the first time, we actually have that the router bandwidth and capacity surpasses the actual traffic demand, and does that in a very cost optimized manner if we take a look at the dollar per bit. And we can look at then the network in a much more simplified way, drive all the switching and the control plane of the traffic onto that IP layer as a single control plane, and drive simplification there. And if you take a look at also the optical systems, as we spoke about, now like with this pluggable optic, which is the evolution of that transponder shelf that you see here, you can actually plug this into any router in QSFP-DD form factor and get a lot of space, power, and also CapEx savings as well. Now, if we take a look at also how this is going to evolve in even subsequent years, obviously as we go higher in speeds, the distances that we can go without coherent technologies becomes less, right? So basically, what we could do in 10 gig era with gray optics, we would need actually coherent technology in 400 gig if we go above 10 kilometers. And if you take a look here, this is an analyst report from Signal AI, and we can see that the coherent ports are expected to continue to exponentially increase year over year.
Now, I have a quick question, real quick.
Please, go ahead.
So I think that you've talked about coherent optics, but it might be worthwhile to explain a little bit more about what that actually means. That's a little bit of a specialty knowledge base there.
Sure. I'm gonna go through it in some of the subsequent slides, but just at a high level, basically, for us to basically transport, traffic over, longer distances, we need coherent technologies, which means that we can convert that into a DWDM type signal and carry that over basically longer distances, right? And having a pluggable optic, we can, put this coherent technology onto the optic and start the DWDM signal from the router, right? So it's basically around starting your DWDM. And we're going to talk a bit more about like how this is connected in the network and how that looks like in just the next couple of slides.
Okay, thank you. I think another quick data point just for clarification early on is, and you can correct me if this isn't the same thing, but it sounds like what you're referring to is packet optical solution. Right. What has historically been called packet optical?
It's really around like how do you take basically if we take a look at today how we do connectivity, right? We take traffic from the IP layer, we take that down into the optical layer where we can basically go from go into the optical domain and go to longer distances. And we're basically now doing that coherent technology into the router itself, right? So other systems that were there in the past can maybe have more of a system that can do packet optical, but in like a full chassis based, which is a totally different technology. But here it's more about having the DWDM signal like starting from the router itself.
Okay. So the other thing I wanted to bring up, and again, stop me if this is something you're going to go over later, but historically you have in a point of presence, you've got an optical shelf, transponder shelf. That's your DWDM layer. That's your layer one.
Yeah.
And separate from that is your layer 2, layer 3, your frame and packet layer. What you're talking about is converging those all down into one platform.
Exactly.
Okay.
And I'm going to show you this on the next couple of slides and exactly how you do that step by step.
Sorry, I jumped ahead a little bit. Thanks.
No worries. Thanks, Nick. So if we take a look at IP and optical networks today and how they actually look like, if I overlay them on top of each other, we're going to see that obviously the majority of the services that operators provide today, they're actually done over an IP network, right? So if we take a look at business VPN services or residential services or broadband or mobile services or IoT type services, all of those are actually delivered over the IP network. And then we have, a smaller subset of services that can be delivered directly through the optical layer, in cases where customers are asking for private line circuits that are traditionally kind of delivered over like an OTN switching layer or wavelength type services. And if we take a look at how the network is actually designed on the IP layer, we basically have an end-to-end network, from the access to the aggregation to the edge to the core into your peering and your data center, interconnects. And then beneath that, if we do the mapping, we're going to see that, on the access layer, when you have your routers, you've got your gray optics plugged into those routers. And if you want to go for longer distances than those gray optics allow, you would need a low-cost amplifier to allow you to do that, right? And depending on the case, you might have like a passive MUX and DMUX. As we get into the aggregation and the core part of the network, we get into a ROADM switching layer. Think of that as the switching that is done in the optical domain, right? And that kind of it comes to be like a hub and spoke architecture with like a full mesh type of design, as you can see here. And basically, depending on the distance, if this is more than 1,000 kilometers, that would be like a long haul network. If it's less than 1,000 kilometers, that would be called like a metro or regional network. And then basically between your data centers, you obviously have, a large amount of traffic. And usually we use for those like point-to-point type, designs where we can go, multiple terabits of capacity and go more even than 2,500 kilometers. So basically, what are the challenges here with managing such a network? So you have a totally isolated IP layer from a totally isolated optical layer. And within our customers, you've got separate planning teams, separate operations teams that are trying to optimize for each one of those layers independently. And as a result, you get really inefficient capacity planning. For example, on the IP layer, you are basically aiming for 50% utilization, you're dimensioning for that. And then on the optical layer, you're doing the same thing. And you have a lot of inefficiencies. Also, if you're trying to troubleshoot issues and do the operations of the network, again, completely siloed. You've got separate tools on each one of those layers that does design, planning, and network management. And when you're optimizing for the service, you're not just looking at that service end to end. Regardless of what it's going through, you're actually trying to optimize across the different layers. So if, back to your question, Nick, right? And if we take a look at how this is actually connected today in the actual, environment. So you would have a router, obviously we've got different requirements in different parts of the network, in the aggregation versus edge, core, and peering, which will depend on the routing feature set that's required, the capacity, the scale. But then for us to basically connect over those longer distances and go cross country, we basically have then to connect to a transponder to start the DWDM signal. And that is done via two gray optics. So one on the router side and one on the transponder side. Then the transponder starts that DWDM signal. And then basically now you're in the optical domain. And then you've got a full mesh of like a ROADM cloud where you basically do the switching, but in the optical domain, right? And obviously you've got your IP layer where you deliver the majority of your services as packet services. And then you also might have an OTN switching layer. And what that does is it allows you to deliver services that are typically private line services. Like some customers might be still requesting TDM circuits or like any OTN type interfaces, and that can be delivered over that OTN switching layer. Now, what if we can actually simplify this and spend on a single network and operate a single network instead of having those silos? And we can do that in a phased approach. We can start first by integrating the transponders. And what that means is we can actually get rid of that gray optic on the router, get rid of that gray optic on the transponder, and completely get rid of that transponder shelf that's taking power, space, and it's actually expensive, and move to a more converged architecture where we can have a pluggable digital coherent optic onto the router itself, where you can start the DWDM signal directly on the router. And basically, obviously, this delivers significant savings. But what if we go even a step further, right? What if we look at the network holistically, and given the fact that the majority of the services today are delivered over an IP network, why do we go and we manage two separate layers with OTN switching as well? Why don't we move the private line services and the customers that are connected to those OTN switching layers into the router and totally eliminate that layer to drive simplification and savings? So with that, we have a technology that Cisco drove leadership for, which is called the private line emulation. What that simply means is we're not disrupting the end customer circuit. So if someone has a TDM link or an OTN link towards the end customer, that stays the same, but it plugs into a router. And we can emulate all the typical circuit characteristics from an SLA perspective. Typical circuits have requirements like bandwidth reservation, end-to-end, having a predeterministic path that does not change, so on and so forth. We basically enable all those characteristics to be delivered on an IP network, leveraging technologies like segment routing circuit style that we've basically been driving as well as a new innovation. And with that, you basically have a single network layer with all your services. Now, what if we kind of move even a step further, right? So now we've got switching that's happening in the optical domain to switch traffic, and we've got obviously switching that's happening in the IP domain. Now, what if we simplify further and look at the design and move from that to a single layered network where you have a unified control plane based on your IP MPLS, leveraging segment routing and EVPN technologies, and basically have a high density router, all that can go all the way up to 260 terabits of traffic, so it can cater for all the switching capacity that you would need. Plug in the transponders via ZR, ZR Plus pluggables into the router. Move to a simple line system that does mux, demux, and amplification on the optical layer. That system, by the way, can still do ROADM switching if certain customers still want to do that, or we do an analysis in that part of the network and customers would still like to do some level of switching on the optical layer. That device can still do that if required. And we move to a unified automation stack where we're not looking at the network in a silo, but we basically have tools and SDN controllers and that can actually look at the network holistically.
So I got a quick question. Sorry, I keep interrupting, but there's lots of things I have questions about.
Go ahead.
So, and are you going to talk about how you manage these compared to how they're managed today in a further slide?
Yeah, we're going to talk about that, and also in the 30 minutes that come after, we're going to actually go into the details of all the controllers, what they do, and even show you a live demo as well.
Okay.
And I've got a question as well. So a couple of things that I heard you talk about with respect to segment routing, as well as simplifying and converging the architecture. Are you guys building and testing on SRv6 or SRv6 Plus, or is this SRMPLS, or what versions of segment routing have you tested with this architecture?
Yeah, so basically, as you know, we support both segment routing and SRv6. Obviously, to start with now, segment routing with the SR circuit style, and the focus is on the SRMPLS. And we've been kind of working on those capabilities on, the routers, but also the automation stack that would allow us to do the centralized path computation element with SRMPLS.
Gotcha. Okay. And then my second question is around the seeing some carriers start to move towards leaf spine architectures with EVPN in like metro areas by using the optical transport to abstract the complexity of the physical architecture that you need for leaf spine in a carrier network. Is this one of those types of technologies you're using? I think Deutsche Telekom is seen as doing this. There's a few other carriers that are doing things like this. Are you seeing that kind of metro leaf spine architecture deployment by pushing that complexity down into the physical layer with an architecture like this?
Yeah, I think the paradigm of moving towards leaf switch is definitely something that we also embrace, and it's part of our solution testing of this architecture to move to fabric type designs. But that can be done on the IP layer as well, right? You have a leaf spine architecture. Think of it as more like from a IP to optical connectivity. Think of it like a hop by hop or a point to point, right? And you can establish that same thing, on the IP layer as well with a fabric of leaf spine.
Right. I think my question was more on the physical layer though than the routed layer, because you need that specific physical connectivity to build that leaf spine architecture. That was more of my question, which in a metro area is kind of be harder because you may not always have the exact paths that you need. And I'm assuming this allows you to glue those physical paths together to replicate that leaf spine architecture more easily, or at least I would assume so.
Yeah, so obviously, if you would go and design the network, as a greenfield, we can, control that connectivity from the get-go. Again, if we're talking about the interim where there is an existing connectivity and customers want to have some kind of intermediate state, we also support this in this architecture, right? So there's nothing that prevents us, whether it's the optical systems or the automation stack, that supports, both scenarios.
Gotcha. Okay, thank you.
So that got me thinking about something else.
Go ahead.
And again, if you want to go into this more later, just tell me that one after I ask the question. But so one of the things that is a popular service that carriers will provide in some cases is transport of alien wavelengths. So basically taking an optical wave that you are not, that's using different framing from a different vendor or whatever else outside of your optical domain control, and transporting that basically as an amplification path. You don't get statistics and things like that. What is your, do you have a answer for that as a service?
Yeah, definitely. So alien wavelength is definitely part of that architecture. So, and we can even run this DR0 plus as an alien wavelength over any third-party optical system. And we've actually also, did announcements with, other operators that we've been partnering on with this, like Telia Carrier, for example, that it's a publicly available reference for exactly that. So 100%.
Excellent. Thank you. All right, I'll stop asking questions for a minute now.
No worries, go ahead. So now I mean, just to kind of recap on the automation side. So as I said, the focus is having unified capacity planning, unified path optimization, and end-to-end orchestration and assurance with a single EMS that can manage that converged SDN transport network. Okay, so now kind of, let's talk a bit more about like the major technology shift here that's also enabling this architecture with the ZR Plus pluggables in QSFP-DD form factor. And those can operate, like the ZR would operate in 400 gig. If you go to ZR Plus, you could operate in 400 gig or even lower speeds like 300 and 200 gig. And basically, the major evolution here is, in previous iterations of this, when we tried to do integration of DWDM into the routers, we basically had the component, which is called the DSP, which actually starts the DWDM signal as, let's say, a DSP that's on the router line card itself. And as a result of that, we had to compromise on the number of router ports and reduce the density there. Then we moved to like a CFP2 DCO technology, which was a major shift as well, where we had the DSP onto the pluggable. But as you can see here, it's a bigger form factor. So again, we had to reduce the density and the number of ports on the line cards. Now with QSFP-DD 00 Plus, you have the DSP onto the pluggable, and it's the same form factor of QSFP-DD, whether you're running gray optics or you're running, coherent pluggables of 00 Plus, which actually really enables this major transition without having any specialized line cards or having to do a density trade-off by reducing the number of router ports. And this is also becoming, this is a standard-based approach. So OIF is standardizing the ZR, and the OpenZR Plus is MSA is where the ZR Plus specs are being defined. So that allows as well for interoperability. And Cisco has been super invested in this, and we've been investing a lot in silicon and optics over the past years. And we believe that this is the next major transition that's going to happen in networking. And if you take a look at the announcements we've been making, so we announced the acquisition of Acacia, which allows us to really get innovative high-speed coherent optics with 00 Plus as one of the leaders in the space. Along with previous acquisitions as well, like Luxtera for silicon photonics and Lightwire and Core Optics. But also on the silicon side, for the routing silicon, we've been investing as well, and we acquired Liba, which really got us to those mass scale routing infrastructure that we were able to announce the industry's first 10.8 terabits MPU, and within a year we announced the 12.8 terabits and so on. Now, if we take a look at that architecture, like in a single slide, we summarize, what's everything that, we would be bringing to the market and what are all the components. So on the routing side, we really do have that support of, 00 Plus pluggables across the whole portfolio, from the access into the aggregation, into the edge with ASR9K, and into the core with the Cisco 8000. And we've basically enabled all the latest and the greatest from a segment routing perspective with SR circuit style, moving as well to innovation on EVPN for superior convergence, along with all the capabilities that we have within timing, security, and so on. We're also obviously adding the support of those pluggable optics to have them supported on optical systems. So we've got the NCS2K today that can cater for that. And we'll also be introducing the NCS 1010, which will actually be the same OS as the routers with iOS XR, and will have all the inbuilt programmability with NetConf both for telemetry and config, and will plug in very nicely into this architecture. On the automation side, we've been really focused on getting a unified automation stack, having a single controller, the Crosswork Network controller, which would really allow us to basically have a controller on IP and optical. It has a single UI to make it easy to operate, and has unified APIs, standard APIs, northbound, and has all the capabilities from multi-layer visualization, having the full topology and inventory view, end-to-end orchestration, path optimization, and service assurance. And we're complementing the stack as well with element management capabilities on EPNM, a unified planning tool that could look at the network holistically as one. And we've been integrating with different hierarchical controllers that allow us to basically also look at the network and integrate with brownfield environments on the optical side, the likes of Sedona NetFusion, that Phil is going to next talk about and show demos as well of capabilities across this whole automation stack.
So in the slide we showed, because I've actually got a client, I do design and consulting for service provider architectures, and there's a one that we've got NCSs on. It's like a 4x100 gig ring in a metro area. Are you saying that you could retrofit an existing like NCS build with coherent optics that would fit into this architecture as far as the management and orchestration of that framework? I know there's newer platforms that you showed, but I'm curious about the existing platforms. I just wanted to verify that you can retrofit an existing build.
Yeah, so the ZR0 Plus is in QSFP-DD form factor. So if you've been using, for example, NCS 5700, Jericho 2 line cards where we had launched that, quite some time back with 400 gig QSFP-DD, then yes, those same line cards can be used for ZR0 Plus. Even on ASR 9K, we've launched a while back the Lightspeed Plus. Again, it's QSFP-DD form factor. On Cisco 8000, again, what we launched back in December 2019, that can also be used as is, right? So on NCS 540, we're introducing, a new platform that has QSFP-DD in the access domain as well.
Got it. What about the NCS 540 though?
Yeah, so on the NCS 540, we're introducing a new form factor that can do QSFP-DD, and there you can plug in the ZR0 Plus. Great. So, if we kind of ask ourselves, like, why now, right? And what's really different this time? I think we've all heard about IP over DWDM before, and there were different terms that were used before, right? So to kind of quickly recap, right? So one major shift that's happening here that we spoke about is you no longer need special router line cards. You don't need to kind of do that density trade-off of reducing the number of ports on the line card, and you actually have that DSP or the coherent DWDM technology starting on the optic itself, and that optic has the same form factor, which drives significant savings. Now, the other thing is all the industry standardization and the multi-vendor interop, which wasn't available before, will actually enable this to become even more of a reality now. The other angle is that we mentioned is as you go higher in speeds, the distances that you can go without the coherent or DWDM technologies become less and less. So what we traditionally knew as gray optics are actually becoming DWDM and coherent optics. The price points as well is another major driver here that we spoke about. If you take a look at the dollar per bit on basically a router port versus the optic itself, and all the automation and SDN capabilities that we're adding so that we can manage the network across the IP and optical in a converged manner. Now, to basically quickly kind of go through a quick recap. So we covered like what would be the evolution journey and how customers can go onto this. So it doesn't need to be like day one you move from this 3-layered architecture with 3 different control planes on IP/MPLS, on your GMPLS, and on your WSON or SSON, and move directly to this converged SDN transport with a single control plane. You can actually do this in a stepwise manner. You can maybe choose to integrate transponders first to start with, next, integrate the OTN switching layer, and then over time also go simplify the ROADM switching that you have in the network. Now, this is basically an example from a customer environment. We've been doing a lot of design analysis and TCO calculations with a lot of our customers globally. And this is an example that shows you the savings that you can get when you move from the present mode of operations into the routed optical networking architecture. And here, in this case, the savings were around 40%. And we get that by eliminating the gray optics that are expensive that we spoke about, by integrating the transponders and getting rid of the dedicated transponders, eliminating the OTN switching layer and integrating those services onto the IP side, and really operating a single network, achieving all the OpEx savings. You can see here on the right the breakdown of savings from power, space, and CapEx and OpEx. Now, to finally kind of conclude here and recap on the journey that customers can embark on, the major transition here and to start with, in this year is really to look at integrating the transponders into the routers via ZR0 Plus pluggables, and basically enable that to run over any existing optical network. So that can run as alien wavelength over existing optical. And then we would also have the automation stack that basically allows us to get there with a unified IP and optical controller, with a crosswalk network controller, and having unified element management on EPNM, and a unified planning tool that allows you to look at the network holistically as a single layer, along with integrations with hierarchical controllers, leveraging the open APIs and the framework that we have there. Next, after doing that, customers can move to simplify and converge all their services onto a single network layer. And they can do this by the new technology of private line emulation. So you basically move your OTN type services and plug them into the router and transport that over an IP network, leveraging the constructs of segment routing, circuit style, and the automation capabilities that allow us to actually do bandwidth reservation, have centralized path computation where you can actually control the path and having it in a predeterministic manner that does not change, just like you do today in typical OTN circuit networks, and get all the visibility from an SLA perspective to maintain the service assurance requirements. And then lastly, the final stage can be customers that can then go and simplify their optical layer even further, move the control plane and move the switching to the IP layer as a unified converged SDN transport network. And again, they can do this in a stepwise manner because any products like the NCS 1010 or the NCS 2K, they actually support full ROADM functionality. So this can be done, as a design approach based on the phases that the customer would like to go into.